The UL simulated aging test for insulated conductors and cables aims to simulate 30 years of aging and assess the durability of these components under extreme conditions. The procedure involves subjecting conductors or cables to a series of heating and cooling cycles. Each cycle consists firstly of raising the ambient temperature to 186 degrees Fahrenheit, which is 100 degrees Fahrenheit above the 310.16 temperature rating. Secondly, submerging the conductors or cables into 32 degrees Fahrenheit water. These cycles are repeated 30 times, simulating 30 years of aging. After the simulated aging test, the conductors and cables are then subjected to various tests to assess their performance. These tests include firstly insulation resistance measurement. Secondly, the dielectric withstand voltage test. Thirdly, conductor resistance measurement. And fourthly, dimensional stability checks. The results of these tests are compared to the original specifications to determine if the conductors or cables meet the required performance criteria. If any significant degradation in performance is observed, the design or manufacturing process of the product may need to be adjusted to improve its durability. This simulated aging test is important for ensuring the safety and reliability of insulated conductors and cables in electrical applications. It helps to prevent premature failure and electrical hazards by simulating the harsh conditions that cables may encounter over their lifetime. This rigorous testing regime ensures that electrical components can withstand the test of time, providing a safer and more reliable electrical infrastructure. Electrical conductors and cables are the backbone of modern power distribution systems. They carry electrical energy from power plants to homes, businesses, and industries. Therefore, ensuring their long-term reliability is crucial for maintaining a stable and safe electrical grid. The UL simulated aging test plays a vital role in this process. By subjecting conductors and cables to accelerated aging, manufacturers can identify potential weaknesses in their products and make necessary improvements to enhance their durability. The heating and cooling cycles used in the test simulate the thermal stresses that conductors and cables experience in real-world applications. Temperature fluctuations can cause materials to expand and contract, leading to fatigue and eventual failure. By repeatedly exposing the conductors and cables to these temperature changes, the UL test accelerates the aging process, allowing manufacturers to assess the long-term effects of thermal stress. The insulation resistance measurement is one of the key tests performed after the simulated aging process. Insulation is the protective layer that surrounds the conductor, preventing electrical current from leaking out and causing short circuits or electrical shocks. Over time, insulation can degrade due to exposure to heat, moisture, and other environmental factors. A decrease in insulation resistance indicates that the insulation has become less effective at preventing current leakage, which can pose a safety hazard. The dielectric withstand voltage test is another important assessment of the insulation's integrity. This test involves applying a high voltage to the conductor and measuring the current that flows through the insulation. If the insulation is weak or damaged, it will break down and allow a large current to flow, indicating a failure. The dielectric withstand voltage test ensures that the insulation can withstand the high voltages that may occur during electrical surges or faults. Conductor resistance measurement is used to assess the condition of the conductor itself. The conductor is the metallic core of the cable that carries the electrical current. Over time, the conductor can corrode or become damaged due to exposure to moisture or chemicals. An increase in conductor resistance indicates that the conductor has become less efficient at carrying current, which can lead to overheating and energy loss. Dimensional stability checks are performed to ensure that the conductors and cables maintain their physical dimensions throughout the aging process. Changes in dimensions can indicate that the materials are degrading or that the manufacturing process is not consistent. Maintaining dimensional stability is important for ensuring that the conductors and cables fit properly into electrical equipment and that they can withstand the mechanical stresses of installation and operation. The UL simulated aging test is not just a one-time assessment. It is an ongoing process that manufacturers use to continuously improve the quality and reliability of their products. By incorporating the results of the aging test into their design and manufacturing processes, manufacturers can create conductors and cables that are more durable, safer, and longer lasting. This benefits consumers, businesses, and the electrical industry as a whole. The relevance of the UL simulated aging test extends beyond individual products. It also contributes to the overall safety and reliability of the electrical grid. By ensuring that conductors and cables are able to withstand the harsh conditions they encounter over their lifetime, the test helps to prevent premature failures and electrical hazards. This reduces the risk of power outages, equipment damage, and electrical injuries. The UL simulated aging test is a critical component of the electrical safety system. It provides a rigorous and objective assessment of the durability of insulated conductors and cables, helping to ensure that these essential components can perform their intended function safely and reliably for many years. This contributes to safer and more reliable electrical infrastructure for everyone. The test also helps to promote innovation in the electrical industry. By identifying potential weaknesses in existing products, the test encourages manufacturers to develop new materials and designs that are more resistant to aging and degradation. This leads to the development of more advanced conductors and cables that can meet the ever-increasing demands of modern electrical systems. The UL simulated aging test is a valuable tool for ensuring the long-term performance and safety of insulated conductors and cables. Its rigorous procedures and comprehensive assessments provide manufacturers with the information they need to create high-quality products that can withstand the test of time. This benefits consumers, businesses, and the electrical industry by reducing the risk of premature failures, electrical hazards, and costly repairs. The 310.16 temperature rating referenced in the procedure is a key aspect of understanding the context of the aging test. This reference points to a section of the National Electrical Code, or NEC, which provides ampacity ratings for conductors based on their insulation type and operating temperature. The ampacity of a conductor is the maximum amount of current it can safely carry without exceeding its temperature rating. The 310.16 table in the NEC lists the ampacity ratings for various types of conductors at different operating temperatures. By raising the ambient temperature of the conductor to 100 degrees Fahrenheit above the 310.16 temperature rating, the UL simulated aging test effectively accelerates the aging process. This elevated temperature puts additional stress on the insulation and conductor, simulating the long-term effects of heat exposure. The subsequent submersion in 32 degrees Fahrenheit water creates a thermal shock that further stresses the materials. This rapid temperature change can cause expansion and contraction, leading to cracks or other damage in the insulation or conductor. The combination of elevated temperature and thermal shock makes the UL simulated aging test a highly effective way to assess the durability of insulated conductors and cables. The test helps to identify potential weaknesses in the materials or manufacturing process that may not be apparent under normal operating conditions. By subjecting the conductors and cables to these extreme conditions, the test provides a realistic assessment of their long-term performance. The results of the UL simulated aging test are used by manufacturers to improve the design and manufacturing of their products. If the test reveals any significant degradation in performance, the manufacturer may need to make changes to the materials used, the manufacturing process, or the overall design of the conductor or cable. These changes can help to improve the durability, safety, and reliability of the product. The UL simulated aging test is an important part of the overall process of ensuring the safety and reliability of electrical systems. By providing a rigorous and objective assessment of the durability of insulated conductors and cables, the test helps to prevent premature failures, electrical hazards, and costly repairs. This benefits consumers, businesses, and the electrical industry as a whole. The test also helps to promote innovation in the electrical industry by encouraging manufacturers to develop new materials and designs that are more resistant to aging and degradation. This leads to the development of more advanced conductors and cables that can meet the ever-increasing demands of modern electrical systems. The UL simulated aging test is a valuable tool for ensuring the long-term performance and safety of insulated conductors and cables. Its rigorous procedures and comprehensive assessments provide manufacturers with the information they need to create high-quality products that can withstand the test of time. This contributes to a safer and more reliable electrical infrastructure for everyone.